and welcome to the Inside Jam September Super Sessions. This is session 1. Hope you're having a great day. I'm your host, Ryan Daly, and we're taking our regular Friday jam sessions and blowing them out to a full day of jam-packed with expert discussion and insight. This is our first session, generating AI-ready data, what every data engineer must know. So if you are watching the live stream here with us on InsideJam.com, please feel free to ask questions in the chat. This is a pre-recorded session, but we will do our best to answer those questions if anybody's watching along or after the fact. If you're watching on YouTube after the recording, it's going up on there. Please leave us a question down in the comments. Leave us a comment if you like it. And if you do like it, hey, be sure to hit that like button and join our now 1 million subscribers. We just hit it. Thank you to everybody who has subscribed. And you know what? Go ahead and be that 1 million and one, if that's a term. All right. And while you're there, go ahead and check out all the AI content, the enterprise tech content, and do head over to InsideJam.com. Join our experts over there and experts of enterprise technology, users of enterprise technology. Join that human conversation around this AI moment because everything we're talking about does relate to that. So speaking of human conversation, let me turn it over to our moderator and our panelists today, Sanjeev Mohan. How you doing, Sanjeev?
I'm doing great, Ryan, and I love your introduction. Happy to be jamming on this Friday.
Thank you. Happy to be jamming with you. Yes, a happy jam to all of us.
I want to welcome everyone. So Ryan, today we get to talk about such an exciting topic. I'm so thrilled to be moderating this discussion because the topic that we are going to talk about today is so central to every enterprise AI initiative. And that topic is AI-ready data.
So I'm going to step out of your way and let you take it away and introduce our expert esteemed panel. So have fun.
So before I do the introductions, I just want to lay the groundwork for a few important things that I wanted to say. Every day, we are literally inundated with information about a brand new large language model, how AI agents are going to change the world. But in all of this discussion, the real challenge sometimes never gets talked about. And that challenge is not building the agent, it is ensuring that your data is accurate, it's trusted, it's governed, it's accessible at the time when the agent needs it or the business comes asking for it. Because uh, AI ready data is such a hot topic these days. So I am constantly badgered with questions like, what does AI ready data actually mean in practice? How does one get started? Are there any lessons that we have learned from people who've been doing this well? I could not have asked for a better panel because these are the people I go to when I have questions like this. The first person on my panel is Guy Adams. Guy was my co author for Data Products for Dummies. So I'm going to go around the table and have you introduce yourself. So, Guy, let's start with you.
Thanks, Sanjeev. Great to be here. So, Guy Adams, I'm the co-founder and CTO of DataOps.live. I've been in the data space for approaching 8 years now. I'm from the software development world. And I've been in AI from the pretty early days. I was doing AI or some version of it sort of 15 years ago when we were doing things like time series forecasting. But today, AI is critically important to us for two reasons. First of all, we're making huge and heavy use of it within our own organization to help us develop products faster, meet customer needs faster, but also because we build a DataOps platform, a lot of what we are helping our customers do is build their own AI applications, and particularly the applications and the data that goes into those. So for us, AI-ready data is really kind of the cornerstone in many ways of what we're helping our customers do today. And it's a really interesting time. A year, 18 months ago, we hadn't really even sort of, thought about some of these. In a couple of years' time, this is all going to be bread and butter, but we're really at the time now where so many organizations are trying to get their head around these questions. What is AI-ready data and how do I get there? So really exciting time.
Thank you. Thanks, Guy, for coming to this show. I'll move on to Aniket.
Thanks, Sanjeev. Happy to be here. I'm Aniket Kulkarni. I'm the software architect for AI and cloud at Dremio. Dremio, at its core, really is a data lakehouse engine. And as Sanjeev and others have led the introduction of what we are doing today, data lakes or data is ubiquitous. And over the last, as Guy said, 18 months or the last couple of years, AI and AI ready systems have become just as common. And at Dremio, we are trying to actually combine both of them to have a AI ready, AI enabled, and AI native data processing data lake engine for you.
That's great. Andreas, you next.
Thank you. Thanks, Sanjeev. Yeah, my name is Andreas Blumauer. I'm SVP Growth here at Craftwise, which is a company relatively new, but was built as a merger on top of two companies which have been around for 15 years plus in the field of data quality, making data and content ready for insights to make data available for knowledge management. And the same principles we've been working on are now applied for AI readiness. So in reality, it's all about contextualizing the data the right way, bringing it together, linking it the right way, and adding a so to speak translation layer on top of the existing data. I will talk about that later. So GraphWise is using knowledge graphs for that purpose, and that's an essential piece of an AI architecture when it's all about to build a semantic layer on top of the data silos. So that's us, and I'm looking forward to this great panel.
Oh, welcome, Andreas. I cannot wait to get into knowledge graphs and semantic layer, but we'll wait to get to that. Let's get to Durgesh. Durgesh has been on my Depends podcast in the past. So Durgesh, welcome to this panel.
Thanks, Sanjeev, for having me again. This is always exciting. So I'm Durgesh Mankekar, VP of Engineering at Prometheum. We provide product for self-service data for the AI ready world. The way we do this is by having an open data fabric, which allows zero copy federation across multiple data sources, and also an agentic platform that allows enterprises to talk to their data. And as you can imagine, what we really need for this is good data that is really ready for AI, which means speed, accuracy, and having the right context. So I'm so super excited to be on this panel.
Very nice. Let's get started. Can't wait to get deep into this. Before we get started, by the way, there are a couple of Gartner surveys and stats I came across. I just wanted to use these to kick off our discussion. The first one that I came across was where Gartner says that 63% of organizations that they have surveyed do not have or are unsure if they have the right data management practices for AI. The second stat that I came across is where Gartner predicts that through 2026, organizations will abandon 60% of AI projects because they lack AI ready data. So, this is how deep Gartner has gone into this concept of AI ready data. But it begs a question, and that's the first question I have for the panel. Guy, I want to start with you. And my question to you is AI ready data just good data, or what makes it different?
It would be nice if it was that simple. I think first of all, looking at the Gartner survey, like 63% either don't have or they're not sure they have the right data management practices. I would say the majority of the 27% don't understand the question, honestly. Like, say, over a quarter of people are happy that they've got this completely nailed. I think they just completely misunderstood what was being asked. But I like the term that Gartner are using there. It's data management practices. They're not talking about just data itself. And that's, to me, I think that's the fundamental difference between AI ready data and just good data. I think, to me, AI ready data covers fundamentally three things. First of all, yes, it clearly does cover the data itself. And that has to be good data. It has to be high quality, it has to be accurate, it has to be timely, and many other things we'll discover and discuss through this panel. And obviously there are elements of it which are more AI specific, where you say, okay, well, does my data have biases in it? Is it a fair representation, and so on? But that the data itself is just one piece. I think the second piece that's critically important that Gartner very strongly alludes to there is the management of the data. how is it governed? How is it deployed? How is it versioned? How is it monitored? All of those operationalized things around the data, I would say, are as important as the data itself. And I'll give an example in a minute why. And then the third one is context. So to put those last two together, imagine I gave you a table that had the closing share prices for the New York Stock Exchange for every day in 2026. So, well, this is fantastic. I'm going to make an absolute fortune, but you're wary, you're a bit suspicious. So you analyze the data itself. You take that table of data, and no matter how you analyze it, every which way it checks out, from the basic, hey, there isn't data missing. You start doing things like, well, hey, particular market sectors should move together, and they do. No matter how you analyze that data, it comes out fantastic. Are you gonna mortgage your house and start betting on this data? Probably not. And why is that? Everything about the data says I am good data, and yet suspicious about it, and you're probably not going to bet your house on it. You're going to start asking questions like, where did this data come from? How was it generated? Who generated it? What's their track record of generating things like this? Who's peer reviewed their method? And what we mean is all about the context. Just looking at the data itself doesn't matter how good that data is. If the context around the data isn't well understood, well defined, and available to the consumer of that data, then it's really not going to go very far. So to me, AI ready data, it isn't just good data. It is good data, but it's been productized, it's well governed, it's delivered with the correct context so that it can be trusted by AI systems today and reused for the use cases that we have today. But ultimately, perhaps most importantly, reused for the use cases that AI use cases we haven't even imagined yet.
I love this distinction that you've made, because when you and I worked on data products, some of these productization and all were even true for data product, but a good data may not deliver the context. I have some interesting examples, but I don't want to go into that right now. I want to move on to Andreas and get the panel's view, how they see AI-ready data. Andreas, what's your definition?
AI should be able to reason about all the data enterprises have. So it should make use of data which currently resides in data silos. And when I say silo, I mean different elements. It can be that it's governed in a different way. It uses a variety of metadata. It uses inconsistent metadata. So it's very hard for AI to link the data together in a meaningful way. And here we can help with semantic metadata. So to bring data together means we do it really on the entity level. So I think we're all pretty well equipped with means to do schema mapping. For instance, if you have two tables, you can map them. But we should really look at the entities themselves, the business objects, because queries and activities are typically centered around those. And the beauty always comes in when you can start to link data from structured and unstructured data at the same time. So there's a lot of knowledge about products, projects, employees, materials, whatever, proteins, if we are in pharmaceutical, which reside in unstructured documents, in PowerPoint slide decks, in emails, of course, but at the same time in structured data. Well, and as soon as we've brought that and linked that together in a meaningful way, we should also start to think about, okay, would this digital twin of our data silos, which is now in a better shape in a structured format, would that already contain all the knowledge needed to give meaningful answers? No, because we still have a lot of domain knowledge in our heads. And typically when experts look at the data enterprises provide, they add their own knowledge to make sense out of it. So we can digitize that as well. And here we start talking about so-called domain knowledge models. So we add domain knowledge models like ontologies and taxonomies, like it's a dictionary. So it's a universal dictionary for your data, which brings the data logics to the business logic. So eventually those two layers come together, and it also helps the AI to reason about the data in a more meaningful way. So those are the two elements: linking the data, bring it all together, and adding this translation layer, this semantic layer on top of the existing data landscape. Those are the two things we are focused on helping our customers to make data AI ready.
That's brilliant. It's a bit different from what Guy said, but the goal is all the same. So with that, Aniket, what's your definition?
So I would like to look at it from the end user, the consumer standpoint. So looking at it, obviously the consumer would say, yes, data has to be clean. That's kind of a given. But when we say AI ready, I would apply two high level dimensions to that. So one dimension, as we would expect, is really the context. But the context really means how quickly and how effectively can I convey the meaning behind the data to the LLM so that the LLM's inferences, the LLM, the model itself can understand it better. That reduces, that can reduce obviously wrong inferences, or that can reduce the number of iterations it has to go back and forth on the data, and that actually gets a more efficient response back. Now, but when we say context, it could mean a few different things. It could mean a glossary of sorts where instead of saying something like, "Oh, my lifetime," a column called a customer lifetime value. Well, it's that actually means the average value of your orders times the number of times an order was purchased times the length of the contract, things like that. So this is actually a description that, along with the column together, makes sense to an LLM so that it can interpret that and reason about that column in a better sense. Or even something as simple as semantic descriptions, where making sure that the schema or the way my data is presented to my models has descriptive column names, or even descriptions within that, like not amount one, but something more definitive, something more descriptive about that, and so on and so forth. So having this context and the ability for the LLM to quickly and efficiently access this context when it is without overwhelming it, that is the first dimension. And then the second dimension is, okay, if I'm able to do this on the first dimension, if I'm successful with the first dimension, then I need to be able to suddenly data across disparate silos or different data formats is now suddenly accessible to me, or it becomes fair game for this. That doesn't necessarily mean data from different sources, but also data that is not typically structured. And I know we would get into that as we go along, but that combined with the context dimension together is what gives us AI ready data. And my last comment on the Gartner report of saying, hey, in the next year and a half, maybe 60% of the AI projects would fail. I would actually say that is more of a fail fast kind of a scenario, which I view as a good thing, where people would try to iterate on getting these two dimensions right. And because we are still in the nascent section of this whole domain, so as we go ahead, getting the balance between these two dimensions right is what will drive that. So I'm viewing that as a sort of a good thing as well.
Aniket, I have to say thank you for bringing up that last point. I think there's a lot of fear mongering that's going on right now. There was an MIT report just last week that said 95% of projects don't have ROI in AI. And then it goes on to talk about pilots. Of course, pilots don't have an ROI. I think it's everything is so new. We are literally, like you said, experimenting. So we need to give it some time. But before we get distracted and talk about all these other things, I want to ask Durgesh, what's your point of view for what makes up an AI ready data?
Thanks, Sanjeev. I'm going to echo some of the points mentioned by the panel here, but you are absolutely right. AI ready data starts with good data. That's your just starting point. It's never sufficient for the AI world, because AI world demands features that go beyond just having good data. So what are these additional features? A few things that are really key for us as is, one is speed. These data analysts who depend on the agents, and the agents require this data in an instant. they're not ready to wait for hours or weeks for getting the right pipelines to run or dashboards to be created. So speed is something that's really important. Second thing is accuracy. Again, without actually having all the business metadata, whether it is uh, in catalogs or BI tools, or whether it's in someone's head, as the panel talked about, I think that all has to come into the agentic framework for us to provide accurate data answers. Lastly, access. The data, we need the ability to access data across various ecosystems, because let's be honest, today, none of your AI ready data is going to be in one ecosystem. It could be in Snowflake, Databricks, Dremio, lots of other systems, on-prem systems. So how do you get governed access in an instant to all of this data, as well as all the metadata that ties it all together? Because access, speed, and accuracy, that's what actually brings, for me, everything together. Context, as we have just heard, is the magic word or the secret sauce that actually brings the right data in the right way, so that we can answer questions in a trusted way without hallucinating.
Thank you, Durgesh. Very well put. One interesting thing that I want to share before we move on to the next question is, if I ask chatbot, hey, chatbot, I just lost my job. Give me the list of the highest, tallest bridges in the city. And if the answer comes back, well, the height of Brooklyn Bridge is whatever, that's the wrong answer. It's the right data. But I think this is where AI is understanding the context, and it's instead it should be saying, well, have you thought of, like, applying here, or so that context becomes so important than just spitting out data that's right. So with that, let's the burning question that I have is that, okay, so now that we've established the baseline of what AI ready data means, how do we get there? And I want to open it up and see whoever wants to go first. It's like, what does this journey look like from where we are today? So any takers, who wants to go?
Yeah, I think you asked the question the right way, Sanjeev, because it is absolutely a journey. And you and I have talked about this, in many different contexts. And, frankly, anyone that tells you they know what that journey is going to look like in 5 years' time is a bit delusional. We're too early to be forecasting that far ahead. But I think what we can do, if we look at, some of the world's most forward-looking companies, and we work with many of them, and we look at where we are today, we can certainly say what the first stages of that journey look like. And I think you mentioned this at the beginning, but I think for me, the starting point for this is I've got to sort of identify and compartmentalize my data. For an enterprise to say, is all my data AI-ready data? It's basically a meaningless question. That covers everything from my most critical finance transactions all the way down to the for sale ads on my internal intranet. That's all my company's data. Is it all AI-ready data? Almost certainly not. Do I need it to be? Almost certainly not. So to start doing anything, first of all, you've got to do is put your data in some logical containers, some logical buckets, and that's where data products come in. Data products are just a fantastic way of organizing my data into these self-contained, sensible, discrete units, well-managed units, and now we can start asking questions of each of those units. Say, okay, is my historical sales transaction data product AI ready? That's now a meaningful question. I've come up with a logical grouping of data that makes sense, and now it's broad enough that it answers real world use cases, but it's narrow enough that I can actually ask these meaningful questions. Secondly, and this is a really happy coincidence, if you look at some of the things that are required to be AI ready, for data to be AI ready, things like, as we talked about, it's got to be well governed and well managed. It's got to be change control, and changes have got to be peer reviewed. It's got to be well versioned. It's got to be accessible. These are things that come basically for free out the box if you're building data products anyway. So you take that first step and you say, I'm going to logically segment my data into data products. Actually, simply by doing that, you already move quite a few steps along that journey. And I think the third thing for me is, you've got to think, and I think I said before, you've got to think about the consumer. So a product manager, whether it's a data product manager or a software product manager, a massive part of their job is considering the consumers and the personas that they are serving. How technical are they? What do they already know? What are their goals? Do they want to be engaging with this for 60 seconds or 60 minutes? All those sort of things. AI consumers are absolutely personas in their own right. And product managers should be thinking about them in a way, but they're very, very different types of personas to human beings. In some cases, they're far easier to support. If I've got 50 pages of documentation and context that are required to really understand my data, you try and find a human being that's going to read 50 pages of context before they understand the data. They won't. They'll just dive straight in. They'll get it wrong. They'll misunderstand it. They'll blame the data and move on. So in some cases, the AI is actually a much more forgiving consumer, or a more forgiving persona, because they will do any amount of work you ask them to do, to get to that point. But in other ways, they are still more difficult. They don't have the same lateral thinking. They don't have the same problem-solving skills that human beings still do. So you've still got to be a little bit more prescriptive.
In fact, I had that revelation happen to me one day when I realized that when we worked on data products, we had no notion, there was no generative AI had not yet come into our mainstream. It just dawned on me that a data product is data with metadata and context. So in some ways, Gen AI has arrived to where data products is.
Mhm.
And so thank you for bringing that up. So Aniket, you were going to say something. Can we make brief?
Really quick. So a lot of things, guy, that you said resonated with me. And what I'll add is my experience looking at my customers, looking at my consumers, from over the last 2.5 years. So around 2023, when ChatGPT suddenly burst on the scene, saying have raised to the fastest billion subscribers and so on. The what I saw in my on Dremio's consumer sites, and Dremio is a cloud, a hybrid, as well as an on-prem data lake system. But what I saw our customers do is, I want to be on the AI train, which means I don't know about AI-ready data, but my first step is, hey, can I use Gen AI to be more productive in something like generating SQL queries and so on. That was the first step that everybody dipped their toes in on this journey, and that worked well in some sense. But there were a lot of the factually accurate but zero on empathy thing, like the one that Sanjeev mentioned about job loss and Bridges question that happened. Then over the next year, then we moved from generative AI for just Gen SQL or Gen code or things like that to understanding more around data products, where the business context started to get embedded, either in the schema of the data, or maybe having a business glossary or a business layer, a business governance tool alongside your data lake or alongside your data. And that together, using those two things together, you get better results. And once that's starting to happen, then we saw the personas over the last year or so, the personas that that guy just mentioned. Those personas emerge as in not just personas. I would say that the AI as an interface, or as an API started to emerge, where the customers or end users expect that there is a AI interface, like you expect a SQL interface, a REST API interface, a UI interface. Now you have an AI interface where they expect there to be an assistant, sort of a productivity multiplier for them, who is sitting there right on your screen. You kind of delegate questions to, it will give you some answers, and that helps you do your day-to-day jobs. And finally, what I'm seeing that go towards is have our data ready such that now this ecosystem can go ahead and say, but I gave you answers. It's kind of a thesis right now, but hey, you want visualizations, you want a TLDR really quick? Don't worry, I got you. And have visualizations, have summaries, visualizations, and actionable insights directly built into the system that you're using. So this is the kind of art that I'm seeing, and I'm excited that we are kind of in the action-packed middle of that arc.
That is amazing. Thank you so much. So we've talked about what is AI-ready data, what does the journey look like. My next question is, what is the first practical step? So I'm going to go to Andreas, because Andreas is very intrigued by your introduction, and you were talking about knowledge graphs. So can you walk us through what is the first practical step?
Yeah, sure. So we've heard it already. So the main missing piece is context. So look at all the tables, all the SQL databases. they miss out a lot of context. So you need an application on top which understands the data. So this is where the context comes from typically, but the data itself cannot be used as such for AI applications. So for example, let's say you want to know which products are popular with customers who have probably attended specific marketing events, and you would like to come up with a complex query about that. And now what you typically do, you would manually link up data from sales, from your sales database, from your customer service database, and maybe some marketing tables. So you bring that data in one structure. And I mean, the alternative is now 3 agents run around, fetch the data with some SQL query probably, and then try to link that together in order to bring it into a structure that the query can be answered. It will fail. I mean, we've seen it again and again. SQL doesn't have or provides all the data needed in order to make agentic AI frameworks work. In reality, we are heading towards Graph RAG, right? So this is a RAG architecture making heavy use of knowledge graphs instead of tables only. And you can also include unstructured data, semi-structured data, like for instance, detailed documents and stuff like that. What happens in the background, and to get to your point, the first step really is to stop thinking in terms of tables. So it's really in our heads. There's still the predominant way of thinking is tables, 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 PowerPoint, PowerPoint, PowerPoint. So this is the two tribes you see in enterprises. And the common ground is a knowledge graph, a semantic layer, which goes a little bit beyond what, let's say, the BI community was used to when they talked about a semantic layer. We use RDF, knowledge graphs. It's the resource description framework. It's an open standard. And it's really about entities and nodes, yeah, in a graph, in a fabric, in a data fabric, which are connected to each other by edges. You can define the relationships between those. And the beauty, it's really self-describing. So if this data is being consumed by an agent, it can instantly understand what the data is all about. So if we go to ChatGPT, for instance, it has been trained on schema.org. Schema.org is a widely, heavily used ontology on the web, and it has brings a lot of additional semantics to an HTML document typically. And by that, the results are better when the website has been has used schema.org annotations. And the same principle, of course, in enterprises, you can expand on schema.org. It's a pretty generic ontology. If you work in manufacturing, in finance, or whatsoever, you will probably extend on the schema.org ontology and use other stuff, like in financial, you would use FIBO and things like that. And those ontologies enrich the existing enterprise content with the context we've just discussed. This is this additional context information needed. And that's the first step, really. So you have to get rid of the idea that the data as such will ever bring the accuracy of your RAG systems, of your agentic framework, up to a level of acceptance. Instead, it's good to start thinking in terms of graphs. That's, by the way, also how our brains work, more or less. We also do not have tables, hopefully, in our brains or relational databases. It's more structured and centered around things and how they should get classified, annotated, how they are related to each other, etc., etc. And also abstraction, yeah, like, okay, what's true for a mammal in general is typically also true for every dog and every cat and things like that. So you can really use such structures to make sense out of the data you have in your enterprises, add additional classifiers on top, filter out more meaningful. So the retrieval part in the RAG architecture, the R, is getting by far more accurate and reasonable with a graph in place.
This is fascinating. Thank you, Andreas, for walking us through. So I'm moving along. We talked about the first step. So I want to talk about the end-to-end data engineering lifecycle. we've had modern data stack. We've got ETL, ELT, data ingestion, and we've got all of these pieces that were all built when we were primarily focused on delivering dashboards, reports, and other analytics. But that was before the advent of AI workloads, like you said, like RAG or graph RAG. So the question I have for you, Durgesh, is, are these design patterns still the correct ones to address AI, or do we need to rethink at the architectural level?
Such a great question, Sanjeev. So the modern data stack, as in my opinion, was built for a different era, as you mentioned, ETL, where you wanted dashboards and reports, and you would probably wait for a few days or weeks before that data was cleaned up and made available to you. These practices are not going to disappear anytime soon, but they are fundamentally misaligned with what users expect in this AI-ready world, where they want instant answers. They expect if there are any gaps in their data, they want to correct those as in near real time. And what that means is you need to have real time data access. Uh, we also know that data does not usually in any enterprise data doesn't live in just one system. It's usually in there's finance data, there's marketing data. It goes across various domains, multiple systems in cloud or in or on-prem systems. So how do you get access to this data with a unified zero copy federation engine so that the data is ready to be queried quickly? That's number one. We already talked about the importance of having a unified context, because having all this technical metadata about tables and columns is great, but it does not have the intelligence of specific business terms. It does not have information that may be available in your catalogs or in your BI tools, a past lineage or data dictionaries, as we talked about. So how do we bring all of that together, again, without having to move data? And that's why we need a newer architecture than a typical architecture that uses ETL or ELT or anything like that. The last thing I would mention here is that when we talk about self-service, um, many times when the answers are not the correct answers, you need to actually build that trust with the end user. And to build that that trust, you also need an explainability in terms of like how you can explain your answers and so on. And what this means is that to get the speed, context, and access, we need a newer architecture that does not require lots of data movement or locating where the data is and so on, so that what we propose is this open data fabric, which does the discovery for you. It does not have to move data, but it's also builds the platform for the agents to sit on top of it, where you can ask questions and get the answers quickly without having to move the data. So as Gartner has already mentioned, data fabric is the data management architecture to support these AI use cases, and we fully agree with that. And then that's why the modern data stack may stay on for a while, but the AI ready world definitely needs a new foundation. And for us, the answer is the open data fabric.
So, Durgesh, I want to ask you about this open data fabric. It sounds like we've integrated a lot of individual piece parts, like catalog is now integrated. I want to ask Andres later on, is semantically a knowledge graph also integrated in data fabric? But before we go there, the question I have for you is, how easy is it for me to move from my existing ETL, ELT architecture to data fabric? Do I have to get rid of everything and start from scratch, or can I migrate it easily? Because there's huge cost and disruption if I'm going to a new architectural idea.
Fantastic question again. I think that's where the data fabric comes in. The data fabric does not require you to move data across systems, so you can actually leave the data where it is, and the fabric will have multiple connectors depending on whether it's a data source, it's a metadata source, whether it's a cloud warehouse, whether it's an RDBMS, and so on, so that we can actually connect to that data, get the technical metadata, and run queries directly without having to move the data. And I think that's what reduces the friction, because as we talked about the journey earlier, what this allows you to do is start discovering your data as wherever it is, start asking questions, and initially you'll start getting the answers based on the questions, but it will also tell you what are the gaps in your data, what are the gaps that need to be filled with additional context, as the panel has been talking about, whether that context needs to be filled with catalog information, with graphs. All of that information becomes much more clearer, so that you can continue on to the next step of the journey.
Every time I talk to you guys, it opens up like whole series of questions. So the moment you said open, I'm thinking iceberg, but before I digress and go and see how AI ready data and iceberg overlap, I want to go to Andreas because I am very curious in open data fabric, kind of an integrated architecture. What is the role of semantic layer? How do you prepare the data? We today, or the existing architecture, we have data engineers. Is there a role for knowledge engineers? So I just want to see what is the overlap intersection of semantic layer, knowledge graphs, and a data fabric.
Yeah, great question. I think it's a slow but continuous, let's say, movement I've seen in the past 5 to 10 years. While, the question always was, okay, how can I keep up with pipelines, data pipelines, which are performant, reliable, and scalable? So this is what the data engineer in principle does. This is not going away. So this is it's like plumbing. So you always need that in any house, any building. It's the fundamental. Let's say the pipelines are fundamental, but the way we look at the pipelines in the meantime has changed. So over the past couple of years, so it's now this task building a pipeline also means we need to start to understand what happens downstream, upstream. So in which way will it affect my business? Will my business be affected when I build the pipeline as such? And that brings us back to the question, how can we bake in the semantics of the data in a meaningful way? How can we use this infrastructure to build a semantic layer eventually? And so knowledge engineers have very good data engineering skills typically, but on top of that, they also are very, very close to the actual business, to what the data means to the business, how they can use it for as actionable insights, how to make decisions on top of that. So they really understand the effect it will have. And by that, they are getting more and more, let's say, into the role of an architect who is able to build this bridge between the existing data assets and the knowledge needed on top of that to drive business. And the tools are it's an expansion of tools, obviously. So you need platforms like GraphWise, obviously, to model knowledge models. That's one element, like taxonomies, ontologies. You need to understand probably also how graph query languages make a difference in analytics, like Sparkle, how you can use Sparkle to use a graph, a semantic layer to analyze the data and eventually bring it to the business units. That's another element. And yeah, but as said before, I mean, we go slowly but surely from pipes to graphs. By that, all the data engineering skills are still needed, and on top, you add up more of the knowledge engineering skills, which partly have been around in the librarian science, partly in as a data scientist. You're already familiar, most likely, with ontologies, also natural language processing tools are very important, and you need to understand those in a more accurate way. Yeah, that's the transformation we currently see.
Yeah, that's great. Yeah, thank you, Andrew. That really very interesting to hear the role of how knowledge has become so embedded into this concept of AI applications and AI ready data. So going back to data, one of the things we talked about in the very beginning of this was AI-ready data, not just structured, it's also unstructured. So I'm going to start with you, Aniket, and then I want to ask you, Guy, how are you handling unstructured data and making it AI-ready, along with structured data, not as a silo?
Right. And thanks, Sanjeev. And that last, the tail end of your question holds the key to a more practical and effective answer. So whenever we start talking about unstructured data in this context, we all tend to look at, oh, what is a better way to parse it? How do I get that? On the while, because we have thought about structured data as a solved problem, and we have kept that aside, and we are only concentrating on the unstructured part. Traditionally, that is how your call it your ML engineer or data engineer specializing in unstructured data, call it what have you. Those personas have spent a lot of time using different tools, different kinds of libraries to try and extract specific forms of data. Like I have a bunch of PDFs. Let me try to from a bank or something like that. Let me try to extract different things using Python libraries, using different kinds of things, and then have what comes out of it go feed into a different pipeline that can then be combined with structured data to finally generate answers, right? And anytime you need to explore or try or tweak anything within this, your entire process or a significant part of your process starts over again, because you need to do that. Now, this is where with LLMs helping you, we can actually change this pipeline fundamentally. So at Dremio, and I'm seeing this pattern on at other places as well. But at Dremio, what we are trying to do is actually give the ability to bring and connect the LLM of your choice to the data, to your structured or unstructured data right within your SQL engine, which means that at the call of a function within SQL, your unstructured data and your prompt can actually go into your LLM, which means that fundamentally it is doing things similar to how a person would manually, let's say, take a PDF and manually try that on ChatGPT, or try to upload it on ChatGPT and try to get insights. But the main thing is, if you do that within your SQL engine layer, that means, and have the output, have the inference, the output that it does, be a structured row, as if it was a row of a table. That gives you the ability to combine any data that you already had that was tabular in the past with this new modern way, which where you don't need to be table centric. You can have data of any kind, and you can then explore things pretty quickly. Like I'll give you an example of a bank that a customer of ours that we were working with, and they had, being a financial company, they had to do what is known as HDM compliance reports, which are compliance reports that you do for loan applications done, loans underwritten over a large period of time. And the things that goes into this analysis is the current set of loans that you have been giving, input of the last 20 years of loans that your bank may have given, and a few other statistical, domain specific things. As you can see, some of that is already structured. Others, like maybe old loan documents, they are probably scanned PDFs. And with the ability of bringing all of this together in your SQL layer, in your data analysis layer, so that your analyst can simply say, hey, look at all these PDFs that are there in my data lake, even though they're unstructured, and try to extract key informations like loan rates, this, that, and other thing, as well as loan localities, things like that, and then have that statistical analysis done directly with other tables all along, without leaving, without iterate, without having to go back to your data, your ML engineers, your Python engineers, to try and figure out how to parse if anything changes. That is the key that I see things, that I see everybody going towards, because that is how you become more efficient, more productive. And the last point I would mention, all along, doing this, and then on the side, expecting that the way to access this, the way to do this, the result exploration, and the way to actually do this using a chat-like interface, using a AI-like interface, which is becoming the de facto API, like I was saying, doing both of these things together is where I see a lot of this, domain going, a lot of this going, and therefore unstructured and structured data, the line between those two is blurring a lot.
Yeah, I love this. This unification is such an amazing topic because and some of the things that you said really resonated with me, because I don't need to go to an ML engineer if I want to do sentiment analysis on tweets that are coming on a product that's in my product catalog. I can just write a SQL statement and I can do it. But anyway, I'm going to go to Guy. And Guy, I want to hear from you. What are your thoughts on this topic?
Yeah, I mean, echo what Aniket said. I'm what you said. It's historically, I think, the distinction between structured data and data engineers and unstructured and ML engineers have just been, as Aniket said, based on the tools that they have to use. Different people, different tools. With modern technology, that barrier is just coming down. So if you give an example, a use case, I want to answer, how happy are our customers? The data engineer, I can process all of our surveys that we sent out to people, and it's average of 1 to 10 in each category, and I can average those up very simply, and I can get a result. But now, if you take the world I operate in, it with Snowflake, you can transcribe thousands of audio recordings of customer service calls, in a single function, in a single SQL function, and with another SQL function wrapped around that, you can generate a sentiment analysis. So with no more than a single line of command, I can go away and say, take thousands of calls, transcribe them to text, then come up with a sentiment analysis, and then I can join that onto my survey data. And I think that's where, there was a really interesting word that Aniket used, which is extract. I think a lot of people still miss that, yes, the unstructured data is super different, but for the vast majority of use cases, we are still trying to extract structure from the unstructured. We still deal, and computers still deal with a more sort of quantitative set of things, and you can prove it. If I had to go and do this job myself, if someone said a bunch of call recordings, I would sit down and listen to them with a spreadsheet, and I'd start saying, well, that's good, that's bad, they're happy, they're not happy. I would listen to it as a human being, and I would quantify that, and I would write down, I'd listen to the audio, and then I'd write down what the sentiment was, and then I'd put some scores against it and average it up. So all we're doing is asking the computer to replace the way the person would work, but it's still fundamentally, it's still taking the unstructured data, extracting structure from that, and this is where the LLMs, as Aniket said, are incredibly powerful, and then mixing that very often with my other structured data, and that's where the kind of the final insight for the user really comes.
The question that came to my mind was, when we do all the sentiment analysis, summarize the data, like read vast amounts of data out there, summarize it and present it to me. How do I know it's accurate? Because one of the biggest problems with AI is accuracy, hallucination. And the reason is because my definition of accuracy could be very different from your definition of accuracy. So how do we know? So I want to ask you, and then I want to see if Durgesh has any thoughts on this topic. But Guy, back to you.
It's a brilliant question, because one of the biggest problems with AI is it's designed to sound plausible no matter what.
Yes.
So I build something and my data is good and it works every day, and then all of a sudden something upstream breaks and I start getting junk data in. But what comes out is still sounding plausible, because that's how the systems are built. If you take a BI, if my data looks good and all of a sudden the upstream data breaks, my dashboard looks terrible, and my business users ring me up and they scream and shout at me, and I have to go and fix it. But the point is, in a BI world, bad data almost always is very obvious when you're visualizing it, because graphs aren't designed to give you a particular perspective. They're just designed to show the data. Whereas an AI is designed to sound plausible. So, take my stocks and shares. If all of those things got mixed up and, I had the wrong stock and share values for a particular day for a different ticker, the AI would still confidently predict, go invest in company X, even though the data on the input is complete junk. So this is really where, like, the old world of, and I've rallied against this both in the software and the data world for years, but saying, well, my users will test it, and if there's a problem, they'll come back and tell me. That just doesn't work in the AI world. You can have the worst system, put it in front of users, it will sound plausible, and they might use it for days, weeks, months before other factors tell them that, look, this is not working. So the accuracy is critical, but ultimately, we still go back to that old idiom of garbage in, garbage out. If we want to measure the accuracy and be confident in the accuracy of what's coming out of our AI systems, the first place we have to start is going back to our AI-ready data. How accurate is, or how confident are we in our AI-ready data? And if we can't answer that question, there's no point in looking downstream. If we don't have this strong level of confidence in the inputs, there's no point in talking about how confident we are with the outputs. And you think about the world these days where people, so many people are focused on AI auditability. I've made a decision, I go back to the model, but I need the model to tell me and document and verify where the data came from and how well I can trust it. But if you're looking at the data producers and they're saying, well, I looked at it a month ago and it looked fine, that doesn't work. That's not okay. So I think one of the things that we're really seeing a massive focus on, and we've got some announcements coming out of Big Data London around this, is actually measuring what we mean by AI-ready data. Actually putting quantitative measurements around it so that I can set it up, I can measure it in a particular way, and then I can monitor that in real time so that if that changes, if that deviates, if that drops, I can immediately step in and stop that data flowing to the AI system, stop my users making decisions against it, because they'll confidently carry on. It's a plausible output, but I need some way of measuring myself as the data producer, how good and how AI ready that data is, so that I can offer that level of confidence to my consumers. And it needs to be in some sort of quantitative way. I can give them here is the data certificate almost, that you can trust. The data that went in is good. As long as the model is good, then you can trust what comes out.
Very good point, because we are expecting a probabilistic model to give us very deterministic answer and correct every single time, which is not what it was designed for. I want to ask Durgesh what is his point of view on this topic of
Yeah.
accuracy.
One of the crux of your question is that the accurate is very contextual in terms of like who you're asked, who's judging the accuracy. For example, if you're in an insurance company, a term like premium has multiple meanings, whether you're from underwriting or you're from finance or investor relations or marketing. The term, how you calculate those values could be different, or a closed deal might mean something completely different for finance versus versus the legal department. So while we are talking about all of these technical solutions, and we know AI has made progress by leaps and bounds, we also have to have some humility and know that AI is not always going to answer all the questions right. So what is really crucial that we have observed is that having that human in the loop is there's no replacement or substitution for that. It's not just for catching mistakes or anything, but also builds trust, because AI, with all its context that it already has access to, may still miss very crucial pieces of information that are in people's heads, or it's just organizational or tribal knowledge. So what's really important in at least the way we build this is, if you actually incorporate that feedback from the humans, it actually helps us in an agentic world. It helps the memory to actually use that information to keep continuously improving for the next set of questions that it's going to answer. Or when someone else from a different department answers the question, it applies different rules as dictated by the data stewards at that organization. One other thing that's kind of critically important in terms of like building that trust and getting to that accuracy is being able to explain your answers. Guy mentioned this idea of garbage in, garbage out, or what if something breaks in your system. The one way to actually to improve on that, build on that trust, is to be able to not just show your work, but also be able to say, okay, here are the decisions we had to make, here's the data we found, here are the rules we found, and here's the lineage on how we got this answer. So if a system, an upstream system, has failed or is giving incorrect result, by showing your work and explaining it, we at least tell or alert the user in terms of, okay, here's a gap that you may be having, and hence I don't have enough confidence in the answer I'm producing. That's how you build trust and get to that the holy grail of getting accurate results.
Sanjeev, if I may add a short thing on top of what both Guy and Durgesh said real quick. So these 2 points about having an introspective check, be it human, be it anything else in place. And then what we have seen a lot of our customers do is, rather than that always being the end user consumed, say dashboard or result, that actually goes into a real, a old world table, sort of. You had just mentioned iceberg. So I have actually seen that happen quite a bit, where the AI ready data is crunched. We talked about unstructured SQL processing, combine, do everything, have the checks and balance there, and then do a CTAS to a more traditional form. Think of it as a checkpoint, because it is more of a traditional form of final result or final curated data that is consumed by the end user, which then means that, let's say that's an iceberg table. If you have your upstream data that processing in this AI pipeline that actually fails, in this AI process that fails, if this generates, garbage out, you can again go back to the last checkpoint of your final table, so that it gives you a chance to rectify this. Because yes, this is still probabilistic. It will get better. It will get better. Maybe we do this jam a year down the line. This question would have been halfway solved later, maybe even more, right? But this is how we have seen our customers do checks and balances in real life to get to have your AI ready cake and eat it too, so to speak.
Thank you so much, Aniket. We are completely out of time, but 30 seconds, Andreas. We cannot have a talk about accuracy and not talk about knowledge graphs and graph RAG. You have 30 seconds to close us out.
Graph RAG is an essential part of a hybrid retrieval strategy, which is needed. So typically, vector search is one element, keyword search still important, and graph brings additional metadata into the game. What does it mean? It's no longer just simple tags, right? So it's really a fully fledged subgraph of a large enterprise knowledge graph, which can be used to contextualize a business object for retrieval, also for prompting afterwards, etc. So the graph is like an index, a multi-dimensional index on top of your data, and is complemented by vector still. So it's but vector alone, vector RAG in many cases is not producing accurate data, and by that people have lost trust a little bit. So that's one element why a lot of AI projects have failed. It was quick and dirty. Some kind of chunking was used, and the structure of data got lost, and I mean tons of dollars and other currencies have been poured into data quality, and now we are throwing it away. That's not a good idea. We should keep the structure and the quality, at least what we've built before, and now put something on top with large graphs.
Thank you. I would thank all of you. I know we've run over a few minutes, but thanks for staying, educating us about your point of view about AI-ready data and everything around it. Until next time, thank you for staying with us.
Ryan Daly here again. I want to thank Sanjeev, Guy, Andreas, Aniket, and Durgesh for a great conversation. I hope you enjoyed it as much as I did. If you're watching with us here live on InsideJam.com, stick around. In less than an hour, we'll have our next panel, our next super session coming up. AI infrastructure strategy, build, buy, and orchestrate for intelligence at scale. So if your appetite for AI has not been satiated, more on the way. If you're watching with us on YouTube, please go right down there and like and subscribe. Of course, it's YouTube, so you got to do that. Join the over 1 million subscribers that we have here on the Inside Jam YouTube channel, and check out all the great content that we have here pertaining to enterprise technology and the AI moment. And after you've done that, head on over to InsideJam.com. Connect with these experts that you just saw. Connect with the other users, people dealing with AI in the workplace. Join the human conversation around AI at InsideJam.com. And if you're watching on YouTube, check out our next super session right here.